Scientists have detected traces of water in a distant galaxy. New observations from the ALMA telescope in Chile have provided evidence of water in the most massive galaxy in the early universe. Researchers have also detected carbon monoxide in the galaxy SPT 0311-58, located 12.88 billion light-years from Earth. The detected molecules of water and carbon monoxide are numerous. This is the most detailed study to date of the gas content in a star-forming galaxy, and the most distant detection of water in space. A paper with the results was published in the Astrophysical Journal. SPT 0311-58 is actually a twin galaxy system first observed by scientists with the Atacama Large Millimeter, a submillimeter array, ALMA, in 2017. Both formed when the universe was only 780 million years old, a time when the first stars and galaxies were being born. Scientists believe the two galaxies could merge, and the rapid star formation would not only consume existing gas within them, but could eventually transform them into massive elliptical galaxies, like those seen in the nearer universe. Using ALMA data, we detected both water and carbon monoxide molecules. Oxygen and carbon are first-generation elements, and in their molecular forms, carbon monoxide and water, they are essential for the origin of life as we know it, explains lead study author Srivani Jarugula, an astronomer at the University of Illinois. It's the most massive galaxy we observe at high redshift, when the universe was still very young. It has more gas and dust than other galaxies from that period, which gives us many potential opportunities to observe molecules and better understand how these elements influence the evolution of the cosmos, explains the scientist. Previous studies of galaxies have shown a link between water and dust emission, which can be observed in the infrared. Dust absorbs ultraviolet radiation from stars in the galaxy and re-emits it as far-infrared photons, explains Jarugula. This excites water molecules, which scientists can observe. In this case, it helped us detect water in this massive galaxy, he adds. Studying the first galaxies that formed in the universe helps scientists better understand the birth, growth, and evolution of the cosmos, and everything in it, including the solar system and Earth. Early galaxies form stars at a rate thousands of times faster than the Milky Way, says Jarugula. Studies of their gas and dust content provide us with information about their properties, such as the number of stars formed, the rate at which the gas is transformed, how galaxies interact with each other, and much more, explains the scientist. According to Jarugula, there's still much to discover about the galaxies of the early universe. Our study provides insight into how far out their water is in space. But it also raises an important question. How did so much gas and dust come together to form stars and galaxies so long ago? The answer requires further study of similar star-forming galaxies, the scientist says. These exciting results demonstrate the power of ALMA, says Joe Pesci, astrophysicist and ALMA program director at the National Science Foundation. These molecules, crucial to life on Earth, form rapidly, and observing them gives us insight into fundamental processes in the evolution of the universe, the researcher emphasizes. Goldfish released from aquariums are threatening ecosystems. Giant specimens have been found in the United States. Burnsville, Minnesota, city officials have urged residents not to release unwanted pet fish into rivers and lakes. The appeal was issued after a giant goldfish was found in one of the lakes. Species raised at home and released into the wild can cause significant damage to local ecosystems and threaten native species. The city of Burnsville shared photos showing several enormous goldfish caught during a survey of Keller Lake. Please do not release your pet goldfish into ponds and lakes. They grow larger than you think and contribute to poor water quality by destroying bottom sediments and plants, city officials wrote on social media. In Minnesota, goldfish are considered an invasive species that doesn't occur naturally in an area and can cause significant economic and environmental damage. This also means it's illegal to release them into public waters. Goldfish kept in a home aquarium typically grow to about 5 centimeters in length. However, in the wild, they grow much larger and can be difficult to remove. They reproduce rapidly and can dominate native species. These fish are long-lived, and in captivity, they have been known to live for 20 years or more. Burnsville residents had previously informed the city about the presence of goldfish in Keller Lake, so authorities decided to conduct a study to assess their population. We expected to find goldfish in the lake, but we were surprised by their size, said Daryl Jacobson, Burnsville's natural resources manager. According to Jacobson, goldfish tend to adapt to their environment, so they can be small in a home aquarium, but once released into the wild, they can grow quite large. They are a tough species. They can survive under ice or in water with low oxygen levels, he added. Wildlife researchers are dealing with a similar problem in nearby Carver County, where 50,000 goldfish were removed from waterways last October. This was part of a 3-year plan to study species that cause damage to ecosystems across the United States. But the US isn't the only country dealing with goldfish running wild. In 2017, the Munich City Council in Germany reported schools of goldfish depriving all competitors in local ponds and lakes of food. The problem became so serious that the city threatened to fine anyone caught releasing pets into public waters. Giant goldfish have also been found in British waters. In 2010, a British teenager pulled a 2.2 kilograms, 4.5 pounds, fish from a Dorset lake, measuring nearly 40 centimeters, 16 inches, in length. Canada and Australia have also experienced goldfish problems.